Welcome to the Unit 2, Section 2 video on conditional statements. So, we're going to talk a little bit about conditional statements and the parts of it. Conditional statements have two parts. They have a hypothesis and a conclusion. And they can be written in the form of if blank, then blank. So, if hypothesis, then conclusion. This is written symbolically as if P, then Q, with a P arrow Q. The hypothesis is the part P of a conditional following the word if. The conclusion follows the word then. So let's talk a little bit about identifying the hypothesis and conclusion. So in A, we have one that's fairly straightforward. Okay? If a butterfly has a curved black line on its hind wing, then it is a viceroy. The part following if is your hypothesis. A butterfly has a curved black line on its hind wing. The conclusion is that it is a viceroy. In example B, it is a little less straightforward. A number is an integer if it is a natural number. Now we know what's following the if. That is clear. So let's write our hypothesis. A number is a natural number because that follows if. That means the other portion, the number is an integer, is our conclusion. So this is just written backwards from what we had in A. And that takes us into our next part. Many sentences without the words if and then can be written as conditionals. And to do so, we're going to identify the sentence's hypothesis and conclusion. So it's already written in here for you for part B. All apples are fruit. That's a little less straightforward. Our assumption is that what we have is a fruit. So that's our conclusion. Our hypothesis is what we're presented is an apple. So if the object is an apple, then it is a fruit. Let's hop back to A. The midpoint M of a segment bisects a segment. Well, what we're presented with, the hypothesis, is that we have a midpoint, M. Our conclusion is that the segment is bisected by that midpoint. So the way we would structure this is if M is a midpoint, then M bisects the segment. Now for C, you can get a driver's permit when you're 15 years old. Well, our assumption here is that you can get your driver's permit. Our hypothesis is you are 15 years old, okay? So if you are 15 years old, then you can get your driver's permit. All right, in the next section, we're going to talk about analyzing the truth value. So now that we have conditional statements, we want to determine if those statements are true or false. And this is going to depend on both the hypothesis and the conclusion. So we say that a conditional statement has a truth value of either true or false. To prove a conditional statement false, we assume the hypothesis is true and find an example where the conclusion is false. Remember, we can prove conjectures false by giving a counterexample. Note, if the hypothesis is false, then the whole statement is considered true. And so what I have here is a truth table. These are truth values for conditional statements based on whether the hypothesis and conclusion are true or false. So if the hypothesis is true and the conclusion is true, that one's straightforward. The whole statement is true. If the hypothesis is true but the conclusion we come to is false, then the statement is false. Then if the hypothesis is false, it doesn't matter if the conclusion is true or false. The whole statement is considered true because what we started with was a false statement. So let's do some examples of these and see what we get. So for example 3, if it is September, then next month will be October. Well, it is September. We're assuming that it is September currently, so we're going to say it's true. And as it turns out, when we did this lesson, it was September. So this is true. Then next month will be October. Well, the month that follows September is indeed October, so that's true. So since the hypothesis is true and the conclusion is true, then the entire statement is true. All right, for the next one, if the sky is blue, then the earth is flat. Well, the sky is blue, so that's true. But the earth is not flat, so that's false. So since the hypothesis is true but the conclusion is false, the whole statement is false. And the counterexample for the earth is flat would be just a picture from one of the Apollo programs or one of our satellites that showed that the earth is indeed round. All right, if an angle is obtuse, then it has a measure of 100 degrees. Well, we're assuming that our hypothesis is true here. If an angle is obtuse, does it have to have a measure of 100 degrees? It does not. So that's false, making the whole statement false. And our counterexample would be that you can have an obtuse angle that's not 100 degrees. So you can have an obtuse angle that is, say, 90 degrees. Or I shouldn't say 90 degrees because that's a right angle. How about 91 degrees? Or anything up to 179 degrees, but excluding the 100 degrees. Okay, so just to be a little bit more specific, anything from 91 to 99 degrees, or anything from 101 degrees to 179 degrees. So if you pick any of those, there's your counterexample. Remember, you only need one. And then if an odd number is divisible by 2, then 8 is a perfect square. Well, is an odd number divisible by 2? No, that is false. And it doesn't really matter what the next part is, but 8 is also not a perfect square, so that's also false. So the whole statement is false. And the conditional is but, actually the whole statement is true because the hypothesis is false. Okay? So the conditional is true because the hypothesis is false. Remember, it doesn't matter what the conclusion is. As long as the hypothesis is false, the statement will be true. Now let's talk about related conditional statements. So the negation of a statement, and this is probably going to be one of the easiest concepts that we're going to do here. The negation of a statement, P, is not P, and we write it symbolically as tilde P. The negation of a true statement is false, and the negation of a false statement is true. Okay? This is kind of like making something negative in math. So today is Sunday, if we want to make the negation of this, then we are going to say the negation of this is going to be today is not Sunday. School does not start at 8:20 a.m. So the negation of that would be to remove the not. School does start at 8:20 a.m. So all you're doing is taking whatever your statement is. If it doesn't have not in it, stick not in it. If it does have not in it, take the not out. When writing negations, do not specify the opposite property. Only include whether it is or isn't the original property. So for example, the sky is blue. Don't say that the negation is the sky is purple. Just say the sky is not blue. Another example is we are in Vermont. The negation of that is not we are in South Carolina. It's not a correction. It is just saying that we are not in Vermont. Okay? That's the negation. Let's talk a little bit about related conditionals. So we have already talked about a conditional being a statement that can be written in the form of if P then Q. Okay? So that is a conditional. That's what we've already been talking about. So for example, if you're late, then you're tardy. That's a conditional statement. If you're late, that's your hypothesis, then the conclusion, you're tardy. Now the converse of a statement is formed by exchanging the hypothesis and the conclusion. So we're going to flip our hypothesis and conclusion. So instead of if P then Q, if Q then P. For example, we're going to flip this statement. If you're tardy, then you're late. The inverse occurs when you negate the hypothesis and the conclusion. So we add our nots into our original statement. So instead of if you're late, then you're tardy, if you're not late, then you're not tardy. And the negation is again indicated by the tilde before the P and the Q. Remember, inverse. Think about the inverse of 5. The inverse of 5 is -5. The inverse of -9 is +9. So we use that term inverse in math to talk about positive and negative. Think about it that way in conditionals. The inverse is like putting a negative sign on it. Instead of if you're late, if you're not late. Instead of then you're tardy, then you're not tardy. We are putting a negative sign on our statement by putting the word not in there. And then finally, the contrapositive is the statement formed by both exchanging and negating the hypothesis and conclusion. So you're going to flip it and put your nots in. So if you're late, then you're tardy becomes if you're not tardy, then you're not late. And it's indicated by the symbols as you see there on the right. So we're going to finish off this section by doing some examples of these types of conditionals. Oh, by the way, a good way to remember contrapositive is the longest word. So therefore, you're doing the most with it. That's a good way to try to remember that one. So let's do an example. So let's start off with if an angle measures 80 degrees, then the angle is acute. So let's write the converse. The converse means we flip it. So if the angle is acute, then the angle measures 80 degrees. Okay, we're just going to write our statements first and then we'll determine if the statements are true or false. The inverse, we're adding our nots in. If an angle does not measure 80 degrees, then the angle is not acute. And then for the contrapositive, if the angle is not acute, then the angle does not measure 80 degrees. Okay, so now let's determine if each one is true or false. So let's start off with the conditional. If an angle measures 80 degrees, then the angle is acute. Well, an 80-degree angle is acute, so our starting conditional is true. If an angle is acute, then the angle measures 80 degrees. Well, does it have to measure 80 degrees to be acute? An 80-degree angle is an acute angle, but it doesn't have to measure 80 degrees. So we have a true statement followed by a false statement, so this is a false statement. And our counterexample would be, let's just say 70 degrees. That's an acute angle that measures something other than 80. For the inverse, if an angle does not measure 80 degrees, then the angle is not acute. Again, false, because it can be acute if it does not measure 80 degrees. And our example for that, again, could be 70, but let's switch it up. Let's make it 65 this time. And then if the angle is not acute, then the angle does not measure 80 degrees. That's true because if it's not acute, then it can't equal 80 degrees. So that one would be true. All right, so you'll notice that the conditional and the contrapositive are both true. The converse and the inverse are both false. Let's see if that happens again. So let's talk about if an insect is a butterfly, then it has 4 wings. Well, let's write the converse of that. Remember, a converse, we flip the statement. So if it has 4 wings, then it is a butterfly. And more specifically, if an insect has 4 wings, because we are specifically talking about insects here. The inverse, we negate both of the statements. So if an insect is not a butterfly, then, let me make sure I spell this right, butterfly, then it does not have 4 wings. And then for the contrapositive, if, and remember we have to flip and negate it. So if an insect does not have 4 wings, then it is not a butterfly. So let's see about the truth values of all of these. Starting with the converse. Well, first of all, we have a true statement here at the beginning. Now, a converse, if an insect has 4 wings, then it is a butterfly. Well, a butterfly has 4 wings, but that doesn't necessarily mean that is an insect with 4 wings. So this is false, and our counterexample is some other insect that has 4 wings. So let's say a dragonfly. Okay? If an insect is not a butterfly, then it does not have 4 wings. Well, again, this is false because a dragonfly has 4 wings, but it's not a butterfly. If an insect does not have 4 wings, then it is not a butterfly. This is true because something that's not 4-winged most certainly would not be a butterfly, since butterflies have 4 wings. So again, you notice the conditional and the contrapositive are both true. The converse and the inverse are both false. Related conditional statements that have the same truth value are called logically equivalent statements. Okay? A conditional and its contrapositive, as we just observed, are logically equivalent. These two will always have the same truth value. The converse and the inverse are also logically equivalent, meaning they will also have the same truth value. In this case, they were both false. Now, however, the converse of a true conditional is not necessarily false. All 4 related conditionals can be true depending on the statement. So let's check out a couple of examples of how that looks. So for example 5, we're going to write the converse, inverse, and contrapositive of the conditional statement and determine whether or not they are true. So let's start with the converse of this statement. If tomorrow is Saturday, then today is Friday. Well, the converse, we flip it. If today is Friday, then tomorrow is Saturday. The inverse, we put our nots in. If tomorrow is not Saturday, then today is not Friday. And then for the contrapositive, we flip it and we put in the nots. If today is not Friday, then tomorrow is not Saturday. So let's look at the truth values for all of these. So, if tomorrow is Saturday, then today is Friday. That's true. If today is Friday, then tomorrow is Saturday. That is also true. And if the converse is true, then the inverse has to be true. If tomorrow is not Saturday, then today is not Friday. If today is not Friday, then tomorrow is not Saturday. That's also true, and it should be because the conditional is true. So all 4 of these is true. Let's look at one last example. So first, let's write our conditionals. If a baseball team had the most runs, then they won the game. The converse of that, we flip it. If the baseball team won the game, then they had the most runs. The inverse, we put our nots in. If a baseball team did not have the most runs, then they did not win the game. And then finally, for the contrapositive, we flip it and put in the nots. If the baseball team did not win the game, then they did not have the most runs. Okay? Let's look at the truth value for each of these. If a baseball team had the most runs, then they won a game. That's true. So that means the contrapositive must also be true. If the baseball team won the game, then they had the most runs. That's true, because that's how you win the game. If you have the most runs, then you win the game. And that means that the inverse is also true. So those are a couple of examples where all 4 can be true. That concludes this section of Unit 2. We're going to move on in the next section to deductive reasoning. We did inductive reasoning in this first section. We're going to move on to deductive reasoning in the next section.